We could unit test our onboarding, right? It's perfectly possible to mock these interfaces, test them, but what was much trickier is to compile just our feature with just the dependency that we wanted. So what does dependency inversion do? Essentially, it takes that interface that was in the middle there and moves it inside the module that you care about, that you're writing. Onboarding now as a module doesn't depend on anything outside. It declares its own interface for login. And it's just like what you did when you were writing that class back at the start where you had your sign in with login handler. You didn't go to Apple and ask them to write an interface on authentication services. You wrote your own protocol and depended on that and then injected in the Apple thing. Well, here we've just done that, same idea, but not with a class for unit testing, but with a whole feature, a whole module of code that doesn't allow us necessarily to unit test, but it allows us to run all of that code. It just allows us to run that whole module independently. Okay, good afternoon, everyone. Thanks a lot for coming along to listen to this talk. Today, I'm going to be talking about how, at Skyscanner, we've decoupled some of the dependencies between our modules using an architecture pattern that's quite well known, called Dependency Inversion. I'm going to go into some details about how we've done that and how it's helped. So, well, just to start off a little bit about me. I'm a senior software engineer at Skyscanner. Instead of saying how many years I've been working, I decided to go for the number of apps I've shipped. A bit embarrassed about the other number, but contact me on LinkedIn if you want to follow up on any conversations. And if people aren't aware of Skyscanner, it's basically a way to search for all your travel needs, right? It's flight, hotel, and car hire. I mean, maybe not all your travel needs, but those ones. I wanted to put this in just to give some idea of the kind of scale. Lots of worldwide users. We have to localize our app to 35 different languages. There's a lot of searches that happen, nothing really to do with the app. That's more kind of back-end concern. But please go and visit the website if you're interested. And the mobile team, so more specifically, this is kind of my domain in Skyscanner. The oldest line of code that I could find in our app was about 10 years old. We're about 75-25, so 3/4 Swift, 1/4 Objective-C, which is not ideal. That number does keep coming down. We're getting there. There's about 20-30 iOS engineers at the moment with sort of around 70 modules, although, that number changes quite rapidly. So just to give an idea of the kind of team size, and that's important for the talk, so that's why I wanted to add that in. But just the agenda of the talk. So I'm going to go through, like classic engineering style, what is the problem we're actually trying to solve here, summarize that in goals, going to go through how we solved that, and hopefully end with some key learnings. So kicking off, the problem to solve. Okay, so I'm going to start small, right? I'm going to go through a journey of, how dependencies build up, and the point of this is really, there's lots of developers in this room. You may be somewhere on this journey, you maybe end up where Skyscanner did, or you may be halfway along there, or you may be just starting. So this is a way to kind of like, hopefully introduce this topic for anyone who's kind of in the process of building an app. So you're asked to build a login feature, right? Someone comes along and says, right, we need login, we need accounts, we want our users to be able to log in. And so what do? You turn to Craig, right? Craig's got the answers, so he says, use sign in with Apple, right? That's what you've got to do. You need some sign in with Apple. And straight away, you think, well, how do I do that? I need authentication services. And there you go, you've got your first dependency, authentication services. And now to compile your login feature, you don't just need your code, your login feature code, you also need authentication services as well. And we're off. And you look online, you find some code, and you think, okay, this is working pretty well. I've got my sign in with login handler, I import authentication services, and I'll just start cracking on and start using it. At this point, your code kind of looks like this. It's all, your framework that you rely on and your code is quite tightly coupled together. But you're smart, right? So you think, well, I can't really unit test it like this. So I need an abstraction. And this, I imagine, is something that most people in this room have done hundreds of times. I don't know. You've got a class, you need to unit test it. I'm going to write a little protocol, and then I'm going to inject in the real thing. And when I write my tests, I can inject in a mock, and I can test that I'm calling the right functions. And this is our first example of dependency inversion. You've created your own abstraction. Apple didn't write that for you. You've written auth services protocol abstraction. And so the dependency you now have on authentication services is through something that you have written. And that's important. If you were to add, or if Apple were to have a protocol on their authentication services, you may be depending on an abstraction, but you've not inverted that dependency because that is owned by someone else. So yeah, a simple example, but this is the first example of dependency inversion. Okay, but your login functionality becomes pretty popular, right? Like people start to want login all over the place in your app, and you think, okay, I'm going to package all this stuff up. So on the left, well, the right for you, you see a kind of login set of login code, an interface, sign in with Apple. You've got a protocol, you've got authentication services, and it's used in the onboarding flow, and it's used in a profile kind of login flow. So you've got these two places, they want to use the same code. And you think, right, okay, I'm going to put a contract there. So now, these other places, they don't depend on your real code, they depend on a protocol. So you've sort of abstracted it, but yeah, we'll come on to that. Skyscanner, these are all modules, right? We build our code in a modular architecture, so these all become separate modules. There's a lot of advantages to building your code with modules. You don't have to commit your Xcode workspace, for example. So yeah, these are all modules. So we've got the two modules, which are sort of feature modules on the left-hand side, and then we've got our service module with this abstraction in the middle. But things grow. Now, given time, you don't just have onboarding, but you've got profile. And now profile wants to read things about the user, so it needs auth tokens to do that. And then you've got a data layer in your app, and it wants a sort of identifier from identity. So I'm trying to describe how what starts off as a simple feature with one dependency, identity, can kind of grow in these ways. And now your interface to identity is starting to get quite a lot bigger than what any one of these individual higher level modules actually needs. And the dependencies grow as well, right? So inside identity, we've not only got authentication services, but we might have some library for doing our OAuth stuff. We might have another library in there for parsing our JWT tokens that we get back because we want to look at the information in there. So that's growing. And you come back to onboarding and like, oh, well, all onboarding cares about is signing with Apple. But now the only thing that can actually function to perform that work is this module that also has to compile OAuth stuff and JWT, and onboarding does not care about that at all. So things are starting to look slightly problematic. And then 10 years happens. And 20 to 30 engineers are typing away and doing stuff all the time over those 10 years. And yeah, identity starts to send data, and data's moved to a protobuf, and you've got branch, and then deep linking comes along, and deep linking just screws up everything, right? So yeah, now we've got 70 modules. They're all kind of linking together. And yeah, I mean, we've seen a few of these graphs this conference. And this was one that was actually produced after we'd cleaned up quite a bit of stuff. So yeah, somewhere in here is the onboarding login module. I don't even know if that is it, but it could be. It might as well be. So yeah, this is kind of how things can grow. You start off meaning well. Everyone starts off doing what seems like sensible decisions, and things grow and become coupled. So you've now got your onboarding module. All it really wants to do is sign in with Apple. But it's got to compile the entire app just to be able to have one functioning identity module to do all of that. And this was kind of the situation we were in. This is the kind of problem that we wanted to solve. So because we could only test things like signing with Apple by compiling the whole app, our developer experience got really, really tricky, right? Really, full of toil, full of repeated tasks. So generating the project before we could even start running it or building it was about 5 minutes. The first time we wanted to run it on the simulator, 6 minutes. 1 unit test from scratch, a dry run was 7 minutes. And, so that was not fun as a developer. And then also, annoying things like SwiftUI previews just completely failed in this big giant project. It just wasn't working at all. So to summarize the goals here, what we wanted to do, and I've sort of split them into two. First one being about kind of like developer experience, right? Reduce that compilation time, allow testing to be part of the workflow. If you've got a 7-minute wait time for any one test, you're not going to be doing test-driven development, right? You're never going to be saying, oh, make it fail, wait 7 minutes, make it. It's not going to happen. So, and also like SwiftUI previews as well. They're a useful tool, right? We want to have that stuff. The second thing is more about decoupling and team organization. I'll go into that one later on. But yeah, let's kick off with these. So the thing that we needed really to help solve this was that we wanted a single module feature app. So what we wanted was an app that just was our feature, right? Because then once you've got to that point, once you can just work on the code that you want and just compile the code that you care about, then all of this stuff kind of comes, right? You're generally not working on a feature that takes 7 minutes to compile. You're generally working on a feature, a small part of the app that will take seconds to compile, right? But it's just about breaking it away from all of that other clutter that's built up. And that's where dependency inversion was a pattern that really helped us. So let's go into that. Now, the first thing I want to say is it is not new at all. I mean, I don't know if you guys know about the sort of solid principles of coding. These were kind of coined or published years ago, and the big D at the end there is dependency inversion. And it states, amongst other things, that a high-level module should not depend on low-level modules, and both should depend on abstractions. And this is kind of where we were. A little bit broken up, but this is kind of the situation. We had an abstraction, we had an identity contract, which is a protocol. There was no implementation there, but we still had to import that into our feature module, into onboarding. We still had to write at the top, import identity contract, and then start using it in our class. Identity in this situation would be the low-level module, onboarding high-level module. We could unit test our onboarding, right? It's perfectly possible to mock these interfaces, test them. That was fine, but what was much trickier is to compile just our feature with just the dependency that we wanted. That was made much more difficult by this setup. So what does dependency inversion do? That's what we felt like at this time. Essentially, it takes that interface that was in the middle there and moves it inside the module that you care about, that you're writing. So onboarding now as a module doesn't depend on anything outside. It declares its own interface for login. And it's just like what you did when you were writing that class back at the start where you had your sign in with login handler. You didn't go to Apple and ask them to write an interface on authentication services. You wrote your own protocol and depended on that and then injected in the Apple thing. Well, here we've just done that, same idea, but not with a class for unit testing, but with a whole feature, a whole module of code that doesn't allow us necessarily to unit test, but it allows us to run all of that code. It just allows us to run that whole module independently. And we've introduced another layer. The kind of yellow boxes in the middle there are what we call the adapter layer. And it has one job, this layer, right? All it does is it reads those interfaces, those protocols, and implements them. And it implements them by using the low-level module. So it's a class. Generally, these are just single classes, very basic things. They implement one protocol, and they go off to the low-level module to do that. And that's kind of how it works. Yes, I've changed the name here because now this is not a general login interface. This is a login interface just for onboarding. It's become specific around the domain that's using that service. So you can start to do some pretty cool stuff, right? You can inject in things like a login that always succeeds, right? You can mock this interface and inject in something that always succeeds or something that always fails. You can unit test onboarding. You can compile just your feature And there's a lot of debugging you can do with this, a lot of development you can do with this, but still at this point you're thinking, but hang on, I actually really want to use the real sign-in with Apple on my simulator or on my test device, and these are just mocks, right? These aren't going to help me at all with actually building the thing, so how does that work? Well, you just take the same pattern and you keep going, right? So your identity module can also do the same thing. It can declare its protocols that it cares about, the functionality it needs on the inside of identity. And when you build that module, you inject in what you want. So in this case, we're injecting in the real authentication services because we need that. So that's why that's purple, right? That's the real thing, that's the Apple framework. We want to actually test this thing, so we'll give that the real thing. But we don't care at all about OAuth requests for onboarding. So we're just going to pass in a mock there, and all it's going to do is just return immediately. And JWT parsing, yeah, we'll just print that to the console or whatever. We don't care about that. So now we've got a real thin slice. It's our feature, the production code of our feature, depending on a lower level module, and that low level module has just the thing that we actually care about, which is the implementation of authentication services. And yeah, that is what basically gives us the flexibility to build a decoupled feature module. But yeah, part of this pattern I haven't talked about here too much, which is this kind of like middle part. So feature one, that's what I've been saying is like the onboarding feature, right? So feature one here is, I've called it feature one here because it can apply to any feature, right? Feature one being the kind of higher level feature, usually something that, product wants, and feature two being like at the implementation level, or a kind of service level feature. But feature one, you write your feature, it needs something from someone else, so it's got its own protocol, but what happens in the middle? How does this all get kind of glued together in your app? And so what we've done here, and what, there's another talk yesterday from Trendyol, they also sort of touched on this a little bit, is that there's a special module in our app. And you're going to need a module like this, however you architect your app, because you need somewhere to kind of put your app delegate and start putting things together and start instantiating, other modules and code and, kind of getting the whole thing going. And we call this the app module. And in this app module, there's a bunch of classes called adapter classes, right? And what these do, they have one specific job. There's quite a lot of them, I'll not lie, there is quite a lot of them, but they have one very specific job. They implement the feature, they implement the protocol, from feature one. So onboarding wants to log in with Apple, and they implement it by using the dependency. That's all they do. They should never do anything else, there should never be business logic in there, they are adapter classes. And so you may have lots of them, but they're simple and they do one job. And that's what this app module is. And this is essentially the way that you then can compose and build all of your features and add them together. Yeah, as I said here, the role of this module is simply to compose the functionality of other modules together. That's its only job. So yeah, how does this then kind of work in what we call feature apps, right? This was the big thing that we wanted to try and get to. And this is what has like released all of the extra productivity. So feature apps, let's have a little bit more of them, or a closer look. So again, here's our feature. It's got the app module. This is how we compile the real app. Just talked about this before, using features X, Y, and Z to implement the functionality needed by that feature. And our feature app uses the exact same code from feature one, or onboarding, but it has its own composition layer, right? So that app module for our Skyscanner app, well, that puts together real dependencies. Our feature module, and remember, this only exists in these little standalone apps that you don't ever ship to anyone, right? These are developer tool type apps, right? They kind of sit in your project somewhere and they just reference all of these directories and they pull out this code. But they're nothing to do with what you ship to your users. And these have little app modules inside them, and that's where you can compose whatever you want. You can pass in mocks, you can pass in the real thing if that's what your feature needs, or a combination of the two. And when you run that app, you can customize completely the experience of that. So you could have, on here, we've got two different options for opening this one. It's hard to read, but there's a thing where it opens the search in a kind of like fully network-driven environment, and then there's other ones with mocked examples. You could have a whole list of things. You could say like, oh, I want sign in with Apple to succeed, sign in with Apple to fail. I want it to have an endless loading. You can mock whatever examples you want, and you can see how that's really useful for debugging. Because now, instead of having to actually like create that environment inside your main app, you've got a tiny little feature app that can be completely configured and run in whatever state you want. But as always, there's some exceptions, right? And some of these are kind of choices and some not so, but I just wanted to kind of show at Skyscanner there's a bit more to it than just, hey, that all works. So networking, one thing we learned pretty early on is that even if you've got this kind of decoupled modular architecture, networking being this service layer, you still want to have networking when you're developing pretty much every feature, right? Like every feature we develop has got to search for flights or search for hotels or something. You need to have an actual network connection. And so we chose pretty early that actually there's not a lot of value in decoupling that in the same way. There was also some limitations with our interface, used generics in a kind of awkward way. That was, yeah, okay, so we keep networking. And the other two here are more like positive choices, I would say. Localization. So we've got a module that just deals with localization. And that's very much let's say, a UI layer concern, right? If you don't include that module, we could easily have mocked localization, just returned like the key or whatever, and printed that on the screen, displayed that. Firstly, like your app looks terrible, right? Like if you've just got like localization keys everywhere, you can't really develop that. But also, it's not adding any value, and it's not decoupling the dependencies in the right way. So both localization and also our UI library, we wouldn't want to start sort of mocking away SwiftUI, and in the same way, we don't mock away our design system. These are very high-level UI layer concerns, you don't need to mock away everything, right? Is the main takeaway here. UI layer concerns, I wouldn't mock away. And then at the other end of the spectrum, really awkward but very useful utilities like networking, I would not mock away. So yeah, basically for our three key goals, the feature app really delivered on these goals, and this has now become an absolute standard. Anytime someone makes a new feature in Skyscanner, we start off by creating the feature app, and we ensure that that keeps working, because that's the place where people are going to be able to efficiently make changes and fix bugs as we go. But what about the other goals that we talked about? These are a bit more abstract, but these are all about decoupling and about empowering squads or teams to autonomously develop independently, right? I want to dive into these a little bit. Same pattern, but sort of explain why we chose this pattern over the other options, and they relate to these goals. So just going back to the original problem, right? So this is kind of what it looked like before we'd started inverting things. We had our high-level module that was depending on this abstract interface, and we had our low-level module. And some of you may be thinking, well, hang on, we've gone through all this work, like moving stuff around and making adapters, but why didn't you just do this, right? Just chuck in a mock. You've got your protocol, just mock it straight away. And then you can just mock everything. And then you've got one mock. It solves all your problems. And actually, yeah, it does solve quite a few problems. You could make a feature app like this, right? You could definitely have taken, or we could have taken, our identity contract, mocked it, and made a feature app. And it would have achieved the same goals that I've been talking about. But, this was a sort of pivot, I guess, for engineering, iOS engineering in Skyscanner, and we wanted to try and think through like what were the other options and how could they help. And this is where the inversion idea also has some value, I believe. So let's say we'd gone with that approach of having these mocks. So team A owns onboarding, and team B owns identity, right? So it owns the interface and it owns the implementation of that, right? That's all within the remit of team B. So the onboarding module depends on that interface, which is owned by another team. And what can happen is, if team B want to make some breaking change to their interface, what they're going to have to do is they're going to have to, go through that change, are going to make that change, and it's going to go and break code that actually sits right inside the implementation of other modules. So that could be all over the place, right? That might be nested inside some awful if statement logic, and Team B is coming along thinking, I can't change this by myself, this is too scary, it's going to break everything. It's sitting inside a bunch of tricky code, right? And it can also break the mocks for that feature as well. So suddenly now Team A is a bit stuck, right? They've got this new interface for identity, and their code doesn't really work with it, and everyone basically has to slightly stop and figure this out before kind of moving on. So it doesn't really decouple the relationship between modules very effectively. Take the dependency inversion route, however, so this is what we did go with. And here, Team A on the left, with their feature, their onboarding feature, and they own their own protocol now. And there's 0 links now between feature 1 and feature 2, right? There's absolutely no way that Team B, even if they wanted to, they couldn't break the internals of feature 1, that team's code there. So, okay, like your identity team, feature 2 here on the right, it might change its interface. The place where that's going to break now is this adapter layer. And if you remember, that's got one job. So it becomes way, way, way easier to go and fix that thing when you do break it. You're like, okay, all I'm trying to do is adapt from this requirement into my service. I've got this one place to do it. It becomes a much simpler conversation. And Team A might have 3 or 4 people working on them. They can, 2 of them can keep working on whatever they're doing because they've got their feature app that still compiles, uses their own interface. They can crack on with fixing whatever bugs or adding new features. And then, you still have to have that conversation, right? Your interface is still changing. You do need to change that code, but it decouples it, and it allows much more parallel development to happen, which is generally a good thing. So yeah, the dependency inversion approach, as opposed to simply passing in mocks, really was driven by this idea about this kind of decoupled and autonomous delivery. So yeah, I wanted to briefly kind of talk about our, how this opened up some opportunities on CI. Let me just check that. So yeah, going back to this, so we've got these feature apps now, and we've started to build feature apps for lots and lots of different features. And our development workflow for feature apps is really kind of smooth now. We can compile and test and run all of our unit tests in under a minute, seconds even for some of them. But on CI, we were still in this situation where basically we didn't want to lose the security of testing everything, right? So we hadn't really changed anything on CI. Every single PR required us to build a whole app, run all the unit tests, and run all the UI tests. And this is a lengthy process, right? When code builds up over many years, this had grown to a kind of 45-minute CI run, which actually isn't too bad, but it's not ideal. And this happens every time a change comes to a PR, right? So you might be fixing some things on your PR, replying to some comments, you have to push again, you've got to wait another 45 minutes. Before you know it, it's the next day. These little time issues. Yeah, so yeah, these kind of like time issues can really affect the performance of a team and affect the ability to deliver code. It's basically the summary there. And why not use that same developer experience of, running the small localized app and take that onto CI, right? What's the reason really for running all of these 10,000 tests when all you've changed is a line of code in one feature? And so, we've not quite got here yet, but we've been testing this, and this is basically where we're aiming for, is that we still want to make sure that the whole app builds, right? We don't want people contributing code that breaks that adapter layer, for example, and means that you can't actually build the develop branch. So we're going to define a set of unit tests, which are kind of global unit tests, and a set of global UI tests. And from our early tests, these are going to take a lot less time to run. Okay, we don't need to go into the detailed testing of every single feature. And we're going to build feature apps that are built depending on which directory has had any code changes. So if you change something in a module that is being empowered by a feature app, instead of testing the whole app, you can go just to that feature app and you can run a more localized set of tests there. So yeah, we can really reduce our CI time as well. And yeah, I just wanted to sort of finish with a sort of summary of learnings, key things. So the first one here is really the kind of main point, I guess, to take away in my opinion, which is around boundaries, right? We started off talking about unit tests and how there was a sort of boundary around your class that you wanted to test. Essentially, all I've shown here is that you could imagine that boundary being around a whole feature, a whole set of code. And if you want to test that in isolation, then inverting dependencies from within that module has the same value as it does for inverting the dependencies on your unit test. So yeah, consider this for unit tests, UI tests, and your development workflow as well. The other thing is around decoupling teams themselves, right? It's very important and it's very valuable to be able to decouple teams so that there's a good separation of concern between teams. And yeah, and once your app gets too big, then these compiler-friendly boundaries, as I've called them here, these ways of like separating your code, use them on CI as well, because that will reduce your costs, that will reduce your time. You'll have a much smoother kind of CI process. And that's it. Thank you very much.
Thank you. That was really, really inspiring.